All right, folks, listen to number 45. Let's get started. All right, Manny Ramirez hits a home run so that the baseball just clears the top row of the bleachers 21 meter high, located at 130 meters per from the home plate. The ball is hit at an angle of 35 degrees to the horizontal and air resistance is negligible. All right, so let's draw this. So you have a guy named Manny Ramirez. Oh, that's a beautiful sound. And he hits the ball. And this is the thing I don't like about this problem, which kind of pisses me off. I did solve this. I got a different answer from the back of the book, slightly different. And the reason for that is because it's this part that they put in part C, even though they should word it here. Assume that the ball is hit at a height of 1 meter above the ground. So let's take that into account. So this is going to be 1 meter. So when you set up the equation, we're going to set this up at 1 meter, and the ball is going to be hit at, so the ball is going to be hit at some initial velocity component. We're going to be naught 0 at the angle of theta naught. So V naught is going to be B naught, we don't know. B theta naught is going to be 35 degrees. So this ball is hit, and the baseball is going to hit the bleachers, which is going to be at 21 meters height. So I'm just going to call that H. H is going to be 21 meters. I like to use variable, guys. That just makes it easier for me. So now it's asking for what is the initial speed of the ball. So think about the actual motion. This is going to, so I'm going to call this L. L is going to be the motion, the equation x and y. X is going to be b naught cosine of theta naught times the t. The only unknown is b naught in the time. Well, that even though that varies depending on the distance. And y is going to be v naught sine of theta naught times t minus gt squared over 2. All right, so let's actually solve this. So let's solve for the initial velocity. We don't know the time it takes for it to hit this point, but we can solve for this, get this into account. So we're going to do exactly that. We're going to take this equation and we're going to solve for t. T is going to be some x. Do they give the, oh, they do give the location, and that's going to be 130 meters. Okay. So this is going to be x divided by, we're going to, I guess we're going to take that v naught cosine of theta naught. We're going to take that equation and we're going to plug it in here. So we're going to say that y minus y naught is going to be v naught sine of theta naught x over v naught cosine of theta naught. I'm just trying to make myself room here. Minus g over 2 x squared over v naught squared cos square of theta naught. So once you work that out, you should get y equals some initial velocity in the y direction plus tangent of theta naught times x times the distance it travels minus g x squared over 2 v naught squared of secant square of theta naught. So once you solve for that, you should have that equation. Now let's think about this. Your only unknown is v naught. You are given the initial, this is just going to be 1 meter. This is just going to be the, what is that, 21 meters. V naught is not known. X is 130 meters. So the only unknown is v naught. So once you solve for v naught, you should get v naught equals, what do I have here? That's going to be x, which is 130 meters, cosine of theta naught, the square root of gravity divided by 2 times tangent of theta naught times x minus y naught plus y, which is going to be the h. And therefore, your V naught, once you do the mathematics calculation, you should have 41.68 meters. Beautiful. So the initial velocity so the answer for part A is going to be the initial velocity is going to be, once you solve for that, it's going to be 41.68 meters per second. All right, so let's answer for part B. So that's going to be the initial velocity right here that it's going to hit. All right, find the speed of the, that's the initial speed of the ball, my bad. All right, I lost track of already what I was doing. The time interval required for the ball to reach the bleachers. So, the time required. So, I'm not even going to answer that. You know, if x is going to be 130 meters and you are given the initial velocity of the ball with some angle, then there's your component. So you could use either of these equations to state that the time it takes for this guy to reach the bleachers is going to be 3.1 seconds. All right, the velocity of the component of the speed of the ball when it passes over the top row. All right, so let's answer for part C. So Vx is just going to be V cosine of theta, because I think it's just asking for the speed, right? Or no, the velocity of the components. Oh, well, maybe I am answering that. Okay, so that's going to be 34.15 meters per second, or I'm going to round it there. So that means that the velocity that it takes at this point, the component, I'm going to write this in terms of I-hats and j-hats, is going to be 13 meters per second in the I-hat direction. Add it to, I'm an idiot. So the final velocity is going to be 34.15 meters per second in the I-hat direction, minus 13.40 meters in the j-hat direction. So the component of the final velocity is going to be 36.68 meters per second. Now let's take the 10 inverse. I'm going to put that negative because I don't really care about the negative. That's going to be, they do want it in component form, so I don't even know what they want anymore. So that's going to be negative 13 point whatever the heck that is, divided by that. Oh my god, I'm having a little trouble putting this in the calculator. Divided by that, that's going to be 21.43 degrees, or 4 degrees. That's it, guys. I hope this helps you guys, and I hope you enjoy.